This is AP Calculus, Chapter 1, some review questions, looking at some multiple choice. Find this limit as x approaches 0. Well, we can use substitution for this with no problems. Get negative 3 over 1, which is e. Number 2, if we try to use direct substitution for this, we're going to end up with 0 in our denominator, which we do not want. The top is the difference of two squares. So that numerator factors into a 3x minus 1 and a 3x plus 1. And cancel a 3x minus 1 from the top and the bottom. So now we got the limit as x approaches a third of 3x plus 1. Can evaluate the limit by putting the 1/3 in for the x. And we end up with 1 plus 1, which I like to call 2. That's answer D. Number 3, direct substitution is going to give us an undefined again. This denominator is the difference of two squares. The numerator is the difference of two cubes. Difference of two cubes, you take the cubed root of each of these and put that in the first binomial. So it's x minus 2. As far as signs go, you go same sign, opposite sign, always positive. X squared is this squared. 4 is the 2 squared. Multiply those together, you get this middle term. So those cancel. We can evaluate the limit by putting 2 in for the x's. That's going to give us 4 plus 4 plus 4, which is 12. 2 plus 2 is 4. So I got 3 for this, which is D. Number 4, this function g of x is not continuous at x equals 2. What was the reason? Well, three-part definition of continuity. Is g defined when x is 2? It sure is. It's defined at negative 5. G of 2 is not defined. That's not true. All the above reasons, that couldn't be true because the first one wasn't true. Does the limit exist? Well, let me tell you this right now. Well, let me not tell you this right now. Let's continue. So what's the left-sided limit? If we approach 2 from the left, that would be negative 1. That would be putting a 2 into this. If we approach 2 from the right, that's going to be 3 times 2 is 6. 6 minus 7 is negative 1. That also works. Those are both negative 1. So the two-sided limit exists. So that's not true because it does exist. It is C because this answer does not agree with this answer. C says the limit of g of x as x approaches 2, which is negative 1, does not equal the function evaluated at 2, which is negative 5. And I agree. So those aren't equal. That's why this is not continuous. Number 5, this is approaching infinity. It's asking for the end behavior. And if we're not asked to show any work because it's multiple choice, this is as simple as we got the leading term in the numerator, leading term in the denominator. Those are growing at the same rate. So therefore, this has a horizontal asymptote at 7/2. If you wanted to show some work for that, you could divide every term in the top and bottom by x cubed and evaluate the limit, and you will find that it is 7/2. Number 6, This one's not as simple. Try to evaluate the limit directly. Terrible things will happen. So I'm going to multiply the top and bottom by 2x plus 5 plus 1, the square root of 2x plus 5 plus 1. That's equivalent to multiplying by 1. In the numerator, we're going to get the first term squared, so that's going to be 2x plus 5, minus the last term 1 squared, that's going to be 1. In our denominator, we're not going to multiply it out because it's not helpful. So in the top, this right here is going to give us 2x plus 4. You can factor a 2 out of that and make that 2 times the sum of x and 2. And that's helpful because the denominator has this x plus 2. We want those to cancel. And because those cancel, we can now evaluate the limit. We got 2 on the top. On the bottom, we have 2 times negative 2 plus 5. It's going to be 2 over, it's going to be negative 4 plus 5, which is 1. So that's going to give us 2 over 2, which is 1. A is the correct answer. Number 7, this, I've said it a couple times, I'll say it again, this little fella is super special. We're supposed to find this, and this is going to be 6x minus 5. Yes, I did it that fast. Am I awesome? Yeah, I am, but that's not, me being awesome is not why I did that real fast. Let me show you how to do this limit. Someday you'll be able to do it that fast as well, by the way. It won't be too long. So we're supposed to take, at the top of this fraction, replace function f, replace all the x's in function f with x plus h. So it's 3 times x plus h, quantity squared, minus 5 times the sum of x and h. That's the beginning. Supposed to subtract from that f of x, which is 3x squared minus 5x. Simplifying this, I'm sorry, this is supposed to be x approaches 0. I'm sorry, h approaches 0. I wrote x, and I even said x. So we got to simplify all this stuff. So x plus h squared is going to be x squared plus 2hx plus h squared. Distribute the 3 to that, you're going to get 3x squared plus 6hx plus 3h squared. Distribute this minus 5, you get minus 5x minus 5h. Distribute this minus, and you're going to get minus 3x squared plus 5x all over h. 3x squared and a minus 3x squared cancel. Plus 5x and a minus 5x cancel. So in the top we have these 3 terms which all have an h in them. Let's factor that h out. Cancel an h from the top and the bottom. And now to evaluate the limit, we're going to put a 0 in for any h's we have, and we get 6x minus 5. Excellent. Number 8. All right, this is one of those pain in the rears. Can't evaluate the limit directly. We are going to divide. I just had a weird sound. Oh, my. Okay, sorry. You probably didn't hear it, but I heard it. We're going to have to divide this by x, and it should note that the square root of x squared is going to be a negative x in this case, and that's because our x is supposed to be less than 0. So in the numerator, we're going to have the limit as x approaches negative infinity. We're going to have 2 over negative x minus 5x over negative x. And our denominator, once you put it inside the radical, take the negative x and square it to get it inside there, it's going to just look like an x squared. This is going to be the limit as x approaches negative infinity. We're going to have 2 over negative x plus 5 over the square root of 1 plus 2 over x squared. This is going to approach 0. This is going to approach 0 as x approaches negative infinity. 5 is going to approach 5. And 1 is going to approach 1. That's going to make this 5 over the square root of 1, which is 5. Look in the day. Sorry. Number 9. This function has a vertical asymptote at x equals negative 5. Why is that? Well, let's see. Let's see if we can factor this. The denominator factors into an x plus 5 and an x minus 1. The numerator, I got to do some work for this. Two things that multiply to get negative 6x squared and add to get 1x. I would say that would be plus 3x and a minus 2x. I could factor an x out of this. So I'm saying this factors into an x plus 2x plus 3 and an x minus 1. X minus 1's cancel. There's a hole in the graph at x equals 1. We know there's a vertical asymptote at x equals negative 5. And if we approach this from the left or the right, is it going to go up or down? So we're trying to figure out, if we approach from the right, is it going to be infinity? If we approach from the left, is it going to be negative or positive infinity? I don't know. So let's try to figure this out. Let's make a little table. I will put in, if you approach x from the left of negative 5, that would be like a negative 5.1. If you approach from the right, it would be a negative 4.9. If I put negative 5.1 into the top, it's going to be negative. If I put it into the bottom, it's going to be negative. That's going to be positive. If I put negative 4.9 into the top, it's going to be negative. Put it into the bottom, it's going to be positive. That's going to be negative. So if I approach negative 5 from the left, f is going to approach positive infinity. If I approach negative 5 from the right, f is going to approach negative infinity. If you approach from the right, it's infinity. I'm sorry. Yeah, right's infinity, which that's not what we're saying is happening. If we approach from the left of negative 5, it's going to positive infinity, so I'm saying that C is the answer. Part D, that question, answer D, that's referring to a horizontal asymptote. And E, that wouldn't have a vertical asymptote if we canceled the x plus 5, but we didn't. So number 10, consider the function that you see here. It's piecewise. Which of the following statements are true? Well, the limit of h of x as x approaches 3 from the left is 4. Well, let's see. This is approaching from the left. If we put a 3 into this, 3 times 3 is 9. 9 minus 5 is 4. So that is true. The limit of h of x exists as x approaches 3. Well, that means the left-sided and right-sided have to be the same. So what is the right-sided limit of 3? From the right, it would be x squared minus 2x. If we put 3 into this, we would get 9. Put 3 in here, we get 6. 9 minus 6 is 3. That does not agree with this, so this limit does not exist. That's false. Part 3, h is continuous at x equals 3. Well, it can't be continuous because one part of the three-part definition of continuity is that the limit exists, and it doesn't. So we are looking at A only. Peace.